This is the first video in the chapter about thermodynamics. We're going to start out by talking about spontaneous versus non-spontaneous processes and distinguishing thermodynamics, which this chapter is about, versus kinetics, which we won't talk about until a little bit later. Okay, so we've talked so far in the chapter about enthalpy and about during phase changes. We've started to use words that indicate that something is favored or that something will or won't happen under a particular set of conditions. And so we're finally going to give that a real scientific term to describe what's happening, and that term is spontaneous. So if a particular reaction is spontaneous, so far we have been saying that it is favored, and a more correct definition would be to say that this type of reaction occurs without energy input. So sometimes we say it occurs naturally. It occurs without an extra force acting on it. For example, a process that you are experienced with as someone who lives in a cold weather climate, downhill sledding. So here's your hill. If you take your sled and you put it here on the hill, your sled is easily going to slide down the hill without any energy input. All you have to do is sit on it and it starts to move. This is the naturally moving direction. If you put someone on a sled on a hill, you would naturally expect them to move in the downhill direction. So the opposite of a spontaneous process is a non-spontaneous process. The simplest definition is to simply say that it's a spontaneous process in reverse. In the reverse direction. So it's kind of like taking the negative of that process. We take the opposite of a spontaneous process, we get a non-spontaneous process. And this kind of a process is the kind that we called unfavored thus far. And it only occurs with energy input. So for example, the opposite of downhill sledding would be uphill sledding, aka being pulled, because we all know that sleds do not go uphill. That is not the natural direction that they move in. So a non-spontaneous reaction would be placing the sled here on the hill and having the sled move towards the top. The only way that that's going to happen is with energy input, is with someone pulling you or with you pulling yourself and your sled up the hill. So the non-spontaneous direction is the energy intensive direction. And the favored direction is the spontaneous direction. Now, all of these words that we've introduced, spontaneous and non-spontaneous, those are thermodynamics words. Thermodynamics is one way of understanding chemistry, is to think about how much energy it takes to accomplish a specific reaction. So these words and everything in this chapter is going to be about energy. What this chapter isn't about is kinetics. So when we say something is spontaneous, that it occurs naturally without energy input, we are not saying that the reaction moves fast, that it moves quickly. This is a kinetics word. This is the second way of talking about how favorable a reaction is, and we are going to talk about this a little bit later. But thermodynamics is about whether a reaction is energy favored, and kinetics is about whether a reaction is time favored. So we're going to do this later in the course. Let me give an example of a reaction where this is relevant. So carbon comes in several different forms. The most ordered, long-lasting form of carbon is diamond. very hard and they quote unquote last forever. Another form of carbon is graphite. This is the form found as the soft gray material. So if we look at this reaction and we want to look at the energy of this reaction, the energy says that this reaction is going to be spontaneous. That energy favors going from diamond to graphite. Diamond breaks down into graphite. But as you're hearing me say this, this probably makes you feel uncomfortable, right? Have you ever seen a diamond break down into graphite? No, right? You buy diamonds and you're told that they'll last forever, and they do from generation to generation. So if the spontaneous direction is for this breakdown, why don't we ever see that happening? And the answer is because this reaction is not fast. So it's still favored, it's still moving there so slowly, but no one will be alive to see this reaction reach completion. So in this chapter, we are only talking about the energy of a process, whether a reaction is energy favored. So in the next video, we are going to introduce a new concept called entropy that will help us discuss whether a reaction is spontaneous or not.